Hi everyone. It's a pleasure to welcome you here into this session. I'm Milan Berka. I work as a machine learning engineer at DataSentics, and today I want to share with you our experiences and lessons learned from building MLOps platform around MLflow. So let's get to it. First, I want to sum up agenda for this session. First, I will say a few words about DataSentics, who we are, what we do. Then I will touch on motivation, why we are doing it, what are some common analytical problems we encounter and we try to solve. And then I really want to deep dive into this MLOps topic. How do we understand it, what it means for getting data science model into production, how it fits in our platform. And I want to really show you the demo of how it's done. And then last but not least, lessons learned, next steps, we will touch on them also. Yeah, so a few words about DataSentics. We like to say that we are a machine learning and cloud data engineering boutique. We are based in Prague. And our mission is to really make data science have an impact on organization. Because a lot of times we see that the data science is perceived as something of a silver bullet. It's easy to do it. It's as instant success. But the reality is, and we see it firsthand at our customers and also at our own internal projects, that it's very difficult to have impact on the data science, and there is a lot of stuff that must be done in order to make this real. So this is something we're trying to help with. I also want to mention that we are a proud partner of Databricks and Microsoft, and also of this Data Plus NI Summit. So if you find something of this interesting, please find us at our booth here, and we can have a talk about it. All right, so our motivation, the problems that we commonly encounter, there's a lot of them. It's basically that a lot of times the model ends up just in the experimental phase, and that nobody knows how to put it into production, as I already mentioned. A lot of times it's about that there's so much tools on the market, and it's like everyone's claiming that it will solve your problem, but the reality is quite different, that you have to squeak them and tweak them, and it's something that's not really easy. Also, a lot of times we see that the data science workloads are not fully understood by the software developers and software architects, and this also introduces some sort of friction. So to combat these problems, we assembled a dedicated team. We call ourselves DataSentics, and our goal is to really make the owners of these problems happy. And this, whether it's data scientist or whether it's data engineer, infrastructure engineer, security guy, we really want them to talk together, to have common tools and frameworks that all works together well, to really introduce this culture and this system to make the data science solutions come to reality. And this is our mission. This is something that we want to do. And on the next slides, I will briefly or sometimes deeply touch on these. All right, so first let me introduce some of our toolings that we developed in DataSentics. But before we get into the MLOps part, let me maybe go a little bit earlier in the process and start with something more basic, and that's having a platform where the scientists and engineers and analytics can come in, and they have the data ready, they have an environment where they can do the experiments, they can write a code, a SQL, Spark, and basically maybe do one or two models, and really to have this basic infrastructure and culture setup. We actually took the best of Azure, including Databricks, and we put together an infrastructure template which can be taken to a completely new Azure subscription, and with a few clicks and in terms of a few minutes, you can basically unfold this entire template into your environment. and everything is already there. So we have Databricks there, it's connected to Azure Storage, it's connected to Key Vault, everything is out of the box ready. You have also the DevOps processes set up. We are using Azure DevOps here, and you can come in and start basically writing code, and this everything is in terms of a few minutes basically. And the good thing is that we actually took this to our customers and also to banks, and it works well. And it even went through some penetration tests and security tests, and it stood the tests. So this framework is actually enterprise ready. It's easy to set up, it's fast, and you are able to get up and running in a matter of minutes. The best thing, however, is that we are about to open source this, and it's coming soon. I will mention it again by the end of the slides, but so this is just a teaser. But we are really looking forward to getting this out to you, and if someone wants to get this set up and running in some optimal way, he can definitely leverage our templates and our basic platform for this. Okay, and now to the MLOps. So the aforementioned platform, that's fine, but when you want to get serious and you really want to have tens, hundreds, thousands of models in production running every day with some SLA, you really need to have a little bit more in terms of the system and platform. So this is our now main focus, and this is something I want to now deep dive in. And I want to get to the demo as soon as possible, but before this, let me just briefly touch on the parts that are required to make this work. And these parts are, so first you have some data sources. You basically, whether it's some streaming sources or warehouses or data lakes, you want to take the data, and as a scientist you want to really come up with the features. This is where feature store enter the picture. It should be like one central place across maybe an entire company, organization, to store your features, and it should be curated. You want to register a feature, and it should be taken care of that the feature is of a high quality and it can be used further. And then as a data scientist, you basically want to do some feature store get feature command. You take the features and you start training your models. And if you come out with a new feature, maybe you can register that back to the feature store. Once you have the model trained, you really want to make, like register it. So this is where model registry come into picture. So you want to register the artifacts of the model, but also metadata around it. Who trained the model, what was the performance, what was the features, and stuff like that. And from there, you can basically take the model and you can start thinking about productionalizing it or deploying it or building a serving pipeline, serving application, which will then answer the request on the model. And here, this can come in different flavors. You can maybe spin up API, you can set up a streaming job, or you can set up a batch job. And this is actually quite complex because there's a lot of hidden complexity here, and this is definitely an interesting topic. And then last but not least, we have monitoring. So you want to make sure that all your models are running. You want to monitor that it's running okay, and maybe if the words change and the data that comes into the model changes, you want to know about it, you want to be noticed, and if something goes really sideways, you really want to be able to react to it and maybe retrain the model or come up with a completely different solution. All right. Here I do have like blueprint what we will see in the demo. So now really fast. First, you will see how the experimentation phase begins. Like the data scientist comes and he wants to create an experiment. He wants to do some data analysis. He wants to do some first experiments. He will load the experiments into the model registry. And then once he is done with this and he wants to be serious, then there is this part of creating, like fortifying the code and creating a robust application, which can then be deployed as a retraining application, and once we have this continuous training set up, we also want to move further and start building the serving application, which will then serve the models. And this is like the end phase where the other business processes will then request this serving pipelines and get the predictions. All right, guys, so it's a demo time, and in this demo we will be in Jupyter Lab. We will be here as a data scientist and as a machine learning engineer later, and you can basically do this from anywhere, from local computer, from Databricks, but we have opted for Jupyter Lab, and this Jupyter Lab is hosted in Azure VM. All right, so the first thing, assume that I'm a data scientist and my job is to solve some business problem with a machine learning solution. So I come to the Jupyter Lab, and the first thing I want to do is to initiate my project. I can do this manually, or I can use one utility we developed, which is called MLOps CLI. So let me just use MLOps CLI for this task. All right, and so what I just wrote here, MLOps CLI has this method MDA, which stands for Module Development Assistant, and I will just write init, and the init will initiate this process of creating a new project. So let's just fill in some data and let's create a project. All right, so I just initiated it, and right now what will happen is that behind the curtains the cookie cutter will take place, and it will create a new folder for me. So let's just enter this up, just log in, some password. Now it should just want me to confirm everything. So let me just confirm everything, or maybe I can rewrite something if I want. Okay, so right now we see that we have a new project here, which is called DA. And if I go in, I can see that I already have a template, how this project will look like, or how it looks like. It's initiated from the template. So as a data scientist, I really want to start my job, my process, more on the experiment side. So I have a notebook folder here, and my job right now is to open the notebook, and I can start writing some experimental code. So I go into this notebook folder, and I have already prepared Jupyter notebook for me. And this Jupyter notebook, it's filled with what I just passed into this creation project. So it already has these names and stuff like that initiated, and already has some pre-packaged sort of documentation-like code, which I can now run, and I can start doing my work. So let me just restart kernel, and let's just run these commands. So first is installation of the MLflow. Then we have initialization of some of the important functions we will use further. And now here I have a dummy toy example of Iris dataset, and this is really for me to delete and play around. For the purpose of this demo, let's just keep it there, and let's just try to run this experiment and log it into MLflow. So maybe let me just edit the test size to something else. I'll just save this, and let's just run it. Okay, so this is first time we are running this experiment, so it will create a new experiment with an MLflow. So if I go over to the MLflow, I can see, and if I refresh, I should see, yeah, I see it, new experiment, which is called DA. And I already have this first run locked. And when I open it, I see a standard MLflow interface. And yeah, so I have my parameters, metrics, something I defined in the notebook. And then I have this model file with all the necessary artifacts and metadata to run the model. One very good thing actually is that I have my Git commit here. So right now I can basically connect this run to a certain version of code under which it was run. And this is very neat for reproducibility. Okay, and now if I maybe go with another setup of the experiment. I can run this again. This time it should not really, let me just save it, and this should not really make much difference. So I can go back into MLflow and I can see my new run, and I can see that it has a different git commit and it has a different model score actually, which is interesting. Oh, it's maybe expected. I just changed the train test split and it provides a new model score. All right, this is how I can start playing. And right now, let's assume that it's time to stop playing and start to do some production work. So I actually do have two things I want to do. First is to productionalize this machine learning training pipeline, set up the continuous training, and then I want to maybe think about how to design the serving pipeline. So this is where the machine learning engineer comes in, and together with data scientist, they figure out how to fill up this source template. And here there are several files which must be filled, and one of which is a train model file, one of which is config, and then we have some tests to run. So basically here what I'm trying to do is to take all my experimental code from the notebook and put it into the train model file, which will then be run in production. This will provide a continuous training. So if I open this is how it looks to me if I haven't done anything. So this is again some sort of template, and as a machine learning engineer and scientist, I am here to fill this up. The same goes for tests. So again, I have this prepared stuff, and I just have to put in this new tests, and this is up to me to design. Okay, so maybe let's just switch over to a project that already does have this filled. So we already have this project CRX, which is about credit ratings. And if we go here into the source folder and into the model folder, we already see that these things are pre-filled, or are filled actually. So the machine learning engineer came in, and together with scientists, they actually did their job and converted everything from notebook into this train model file. So here, this particular case is about creating a pipeline, a model that will score a client based on this credit ratings. So we have some pipeline steps here, and then we have this train function filled, and everything is called within this train new model function, which is then called when the training actually is happening. Also, I believe that in particular example, the tests are as it were. So we have this dummy tests, but if we need it, we can definitely bring in some more tests. And maybe the last thing is this MLOps folder, which is to be filled again by the machine learning operations engineer. And here they have the training pipeline and the deployment pipeline, which in our case is built on Azure DevOps, but this is not a big problem to port into GitLab or other automation tool. And this particular pipeline is doing the training of the model based on a Git push. So if I push new code into the repository where the project resides, I can retrain this model. And then we have this deployment, and again on the push, the things will be automatically deployed and ready for test or ready for production. So let's actually do this. Let me just switch. So I just switch into the CRX folder where the Git is already merged with or connected to the remote. And right now, what I can do is that I can change something in the model, some parameters of the model. So I can see that this model is utilizing random forest classifier. So let me just change this value to this. And this can be done by data scientists. So this is we have everything prepared. have the training pipeline set up, and all I need to do is basically to change the code and commit and push, and the training pipeline will just fire automatically. So this is like the next stage. The experiment was playing around. Right now I have this file, I can alter it, commit, push to Azure DevOps, and the retraining will be done automatically. So let's do it. I have created this new parameter, and now let me just push it to the Git. All right, and we are pushed. So right now what will happen is that in Azure DevOps there is already this retrain pipeline which is now reacting to this git push, and it's basically running the retraining algorithm, or this entire retraining process which is defined in the MLOps folder. And if we click into the details, I can see that it's going through the build stage. It's basically taking the artifacts from the Git repo. It's preparing the environment, and the training will soon begin. And maybe one very nice thing about this is that the training is running actually in DevOps itself. So it's running in the machine where DevOps is actually running. But we can set up this to run on any platform that you want. So whether it's Kubernetes server on your on-prem, or whether it's Azure ML, or it's Databricks, or it's some other service, this can be definitely set up. Okay, so we are in the process of retraining. Right now we are preparing the training environment, and soon the training will begin. And after we are done with the training, what will happen is that the deploy pipeline will run automatically. It will take the new model, and it will actually spin up a new ACI, which stands for Azure Container Instances. It will create a new endpoint, and I can directly query it. So this is something that will follow this training. So this is really where the automatization is in its strongest. All right, yeah, so we are installing. Right now we are running the training. Hopefully it will run. If not, it will be a failed run in MLflow. But so far we are generating scripts, and seems that we will get this model done. All right. Yeah, and great. And we are done here. And we are actually running the test right afterwards. So we can see whether the test passed, and if something goes wrong, this pipeline will shut down, and we will not have a new bad maybe experiment doesn't go through tests. Okay, so if I go back to the MLflow and I refresh my page, I should see a new experiment, and it's here, and we really see that it was created before. It's on this git commit, and again we have the new model. And now this was the training. So this is like new way how the data scientists can really train. It's just based on commit on this source folder. And if we go back, we see that the serving or the deployment pipeline to the serving environment is running also. So if I click here, I can go to the stage, and I can see that the release is happening. And again, there are some steps we have to go through. We have to download the model, and then we have to deploy the ACI, which stands again for the Azure Container Instances. And once this is ready, we will see that we can actually access the endpoint, and we can query it directly. And this is all happening automatically. So for me as a data scientist, I have one commit, and everything else is happening automatically with a little work from machine learning engineer to set these pipelines up, and we are here to help them with the templates. Oh yeah, so right now we are deploying to ACI. This might take a while, but once we are deployed, we can actually leverage the new endpoint. Great, and we are done. So right now, let me just grab the new ACI URI, and we already, let me just clear this one up. So we have all these files open, and here I already have prepared post request. So let me just replace the URI, and right now I can basically query query the endpoint, and I get the result. So I have new model deployed into production. Fairly easy, fairly fast, and friendly for everyone involved, hopefully. All right, so here we are. We are at the end of the deployment. And now, very last thing is, which I want to mention, is that this is not very tense. There's like next step in this monitoring. And here our approach is that we build a monitoring library, and this library should really work quite independently on anything else. This is a library that can be run in Databricks or in a special Docker container. And basically, this library is about connecting to data source, which represent the output of the model. Then it has predefined metrics which it can compute, and we are here computing the skew and the drift of the model, or more precisely of the features. And then it can basically push these metrics to a target of your liking, whether it's MLflow metrics, or whether it's some Power BI report, or whether it's just a plot in your notebook. This again depends on what's the preference. So if I go here, I can definitely download these. I can run this, and it's calculating the mean drift and skew. And here I have, yeah, so this is like from 4 days before. We haven't updated the dataset, but basically here I have like the model skew and model drift historically. And if I want, I can definitely plot this, and I can see how it behaves. And if it exceeds certain threshold, I can react to it, either sending some other messages or automatically retrain my model. Okay, so that was the demo. Let's maybe just debrief what we saw. In this picture, it's actually broken into the parts. So we saw the model development assistant in action, creating a new project, creating the templates. Then we saw the MLflow open source in action, this model registry. And then there was this serving part, the serving manager, which is consisting of the deployment pipelines and also the means how to deploy the actual deployment pipelines. And then we have this monitoring and alerting, so model drift, skew monitoring, and alerting if something exceeds threshold. There's a lot of lessons learned that came from this. But one very neat thing in particular was about MLflow. So the open source MLflow is, I would say, quite naked, and you have to really reinforce it with the authorization mechanisms. There is some surprising part where the artifacts actually doesn't go through the MLflow, but you have to upload them maybe via the MLflow client, but directly into the storage underneath MLflow. So there is a lot of lessons learned. We try to summarize on the slides. There's many more. But this MLflow things are of particular interest. And next steps, we just want to push this further. We want to introduce some common interface, front end maybe even, and tighter integration with feature stores and rich deployment offerings. So always on the run. As I mentioned, I want to mention and highlight it again. We are open sourcing the infrastructure part of the basic platform, and we are really looking forward to any feedback on this and any companies that want to go along with us and challenge it and contribute to it. So it should be open source soon. And now, very last thing is kudos to the platform team at DataSentics. And I just want to say that this is part of, or this is work of many people. It's not easy, and we are always looking forward to welcome new members of the team. So this is our call. Great, so thank you very much. I hope you enjoy the rest of the Data and AI Summit, and looking forward to any feedback.